Hello everyone. Welcome to the mini lecture on electromechanical control technology. In this lesson, we will study the structure of servo motor. A servo motor refers to an engine in a servo system that controls the operation of mechanical components. It is a kind of auxiliary motor used in indirect variable speed devices. A servo motor is a special type of motor that can adjust output speed and position based on feedback from control signals. It offers high precision and fast response, making it widely used in mechanical control systems. Our lesson will cover the following three main topics. Through this lesson, I hope everyone can accurately describe the main components of a servo motor: motor body, sensor, power driver, and controller, and their respective functions. You should be able to distinguish between AC servo motors and DC servo motors in terms of structural differences and explain how these differences affect their performance. A servo motor can control speed, and its position accuracy is highly precise. It can convert voltage signals into torque and speed to drive the control object. The rotor speed of the servo motor is controlled by the input signal, and it can respond quickly. In automatic control systems, it is used as an actuator and has characteristics like a small electromechanical time constant and high linearity. It can convert the received electrical signal into angular displacement or angular velocity output on the motor shaft. Servo motors can be classified into two main categories: DC servo motors and AC servo motors. Their main feature is that when the signal voltage is zero, they do not self-rotate, and their speed decreases uniformly as the torque increases. Let's first look at the components of a servo motor. 1. The servo motor mainly consists of four parts: the motor body, sensor, power driver, and controller. 1. Motor body. The motor body of a servo motor typically uses either a DC motor or an AC motor. A DC servo motor mainly consists of an armature sleeve, permanent magnet, commutator, and brushes. An AC servo motor is made up of a stator and rotor. The motor body's parameters, such as quality, power, and speed, determine the performance of the servo motor. 2. Sensor. Sensors are used to detect information such as the motor's position and speed, and feed this information back to the control loop. Common sensors include encoders, photoelectric switches, and Hall sensors. Encoders are the most commonly used sensors, as they convert rotational motion into pulse signals, providing precise information on position and speed. 3. Power driver. The power driver primarily serves to amplify power. It outputs the appropriate voltage and frequency for AC servo motors based on the needs of the servo motor, controlling the motor's torque and speed to meet the actual requirements of the servo system and achieve the expected performance targets. Since a servo motor needs to operate in four quadrants, the power driver must be reversible. Medium and small power servo systems often use PWM converters composed of IGBT or power MOSFET. 4. Controller. The controller is the key component of a servo system, as the control strategy of the system is implemented through the controller. Based on a set position and feedback signals, the controller generates control signals for the power driver using necessary control algorithms. Similar to speed control systems, servo system controllers have evolved from analog control to computer-based digital control. Early servo control systems used analog controllers and analog position sensors, resulting in less than ideal positioning accuracy and performance. With the development of computer control technology, computer digital control has replaced analog control in servo systems, now becoming the dominant technology. Computer digital control offers functionalities difficult to achieve with analog control, such as data communication, complex logic, and data processing, and fault diagnosis. Paired with high-precision digital position sensors, It can enhance the positioning accuracy of the servo system and improve its dynamic performance. Now, let's learn about the structure of AC servo motors. The rotor inside an AC servo motor is a permanent magnet. The U, V, W three-phase electrical current, controlled by the driver, generates an electromagnetic field. The rotor rotates within this magnetic field, while the built-in encoder provides feedback signals to the driver. The driver compares the feedback value with the target value to adjust the rotation angle of the rotor. In this lesson, we will study the structure of servo motor. The stator structure of an AC servo motor is quite similar to that of a capacitor split-phase single-phase asynchronous motor. The stator contains two windings that are positioned 90 degrees apart. One is the excitation winding, RF, which is always connected to the AC voltage, UF. The other is the control winding, L, which is connected to the control signal voltage, UC. Finally, let's learn about the structure of DC servo motor structure. The earliest servo motors were general DC motors, which were used as servo motors when high control precision was not required. Modern DC servo motors, in terms of structure, are small power DC motors. The excitation is primarily achieved through armature control and field control, but typically armature control is used. Servo motors can achieve precise control over position, speed, and acceleration. This improves the motion precision and efficiency of equipment, while reducing energy consumption and noise. Servo motors are widely used in fields such as automation control, robotics, medical equipment, printing and packaging, and textile machinery. Through today's lesson, we gained an in-depth understanding of the structure and working principles of servo motors. And we learned the differences between AC and DC servo motors in terms of structure and how these differences affect their performance. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.